Hey, Algebra 2, it's Miss Green here. We are in week 5 of online learning. This video is about modeling with exponential functions. So at the top of the page we have a function, an exponential function, f of x equals a times b to the x. And you'll remember that b is called your base. And it tells you whether something is growth or decay. So if b is greater than 1, you're going to have a growth function. If b is a fraction or between 0 and 1, you're going to have a decay function. The a value doesn't really affect whether it's growth or decay. So the way the math works is, let's look over here on this growth function. You can tell it's a growth function because b equals 3, which is greater than 1. So we have f of x equals 2 times 3 to the power of x. When x is 0, your function is going to simply be equal to whatever the a value is out front. So notice that this is a 2. And what the math is doing is you're multiplying 2 times 3 to the power of 0. Anything to the power of 0 is 1, so it's 2 times 1, which is 2. And then every single time you increase x by 1, you're going to multiply the previous value by 3. And that's why 3 is called your multiplier. So 2 times 3 is 6, and 6 times 3, which is 18, and 18 times 3 is 54. So that's why it's growth, because every single time you increase that x by 1, you're multiplying by 3. So that thing is tripling every single time. So, and this just shows you what the math is doing. And if x is 1 here, you get 2 times 3 to the 1, which is 2 times 3, which is 6. Then when x is 2, you multiply 2 times 3 squared, which is 2 times 3, which is 18. And when x is 3, you multiply 2 times 3 cubed, which is 2 times 3 times 3 times 3. So you can see why that's called a multiplier, or it's called a growth factor. Okay, same thing happens for decay. When you're multiplying, well, let's start out with x is 0, you're just going to have the a value, which is 7. When x is 1, you're going to multiply 7 by 0.5 to the power of 1, which is multiplying by 7 by 0.5. So it's going to decrease, because when you multiply a number by 1/2, it declines. So every single time you're multiplying by 0.5, your value of your function is going to be decline by 1/2 or by 50%. So you're multiplying by 1/2 every single time, because 0.5 is the same thing as 1/2. So this is why this function is called decay. So you can see why when the b value is less than 1, or it's a fraction between 0 and 1, you have decay. And this is called a decay factor right here. And the other b value is called a growth factor. And when you have a factor, that means you're multiplying. You remember, like a scale factor. So this is called a growth factor. So just want to remind you about what that b value means. Okay, now below, what we're going to do is we're going to, let's move this up a little bit. We're going to talk about two different equations. The one on the left is called a growth equation, and the one on the right is called a decay equation. So in the growth equation, this value right here, this value is going to be greater than 1. And in a decay equation, that value is going to be between 0 and 1. So let's talk about what everything means. The first thing, f of t, is your output. What is the value of the function at time t? And we're going to be talking in terms of time. So what is the value of the function at time t? So y equals f of t. T is time periods in our example. your A value is your initial value. What is the value at time equals 0? Well, the value of the function at time equals 0 is going to be your A value. Then you have your growth factor and your decay factor. So notice your growth factor, you're adding the rate of growth, and then your decay factor, you're subtracting the rate of decay. So I'm just going to show you how these work down below in 2 different examples. In example 1, it says Nadia owns a chain of ice cream stores that operated 5 locations in 2020. She expects the number of locations to grow. So we're talking about growth at a rate of 8% per year. So your rate is 0.08. Because when you write percent, you're going to write 0.08. 8% is 0.08. She started off with 5 locations, so your A value is going to be 5. And they want to know how many stores will be in operation in 2026. Well, the number of time periods between 2020 and 2026 is 6. So your time is going to be 6. So you are going to evaluate the function at time equals 6. So f of 6 equals your A value, which is 5, times 1 plus 0.08 to the power of 6. Okay, so that gives you 5 times 1.08 to the power of 6. And here your B value equals 1.08, and it is greater than 1, so that means it's growth, so you're good so far. So your function, or the number of stores at time equals 6, is going to be approximately, let's use that, 7.934. Well, you can't have 7.934. So in 2026, you're going to have 7 stores. Almost 8, but 7 operating stores. In the example number 2, it says the value of a truck is $28,000. So that's your initial value. And it's decreasing by 9% per year. So this R is 0.095. That's how you write 9%. 9.5% is 0.095. That's called the rate of depreciation when we're talking about assets that are losing value. And they want to know how much will the truck be worth in 5 years. So T equals 5. And your A value is 28,000. So your initial value is 28,000. So they want to know, what is the value of this truck in 5 years, given that its initial value is 28,000, and it's 1 minus 0.095 to the power of T. So that's the same thing as 28,000 times 0.905 to the power of 5. That should be a 5. T is 5. Okay, right here you should notice this is your B value. Your B value equals 0.905. It is between 0 and 1, so we're talking about decay, so you're losing value. What this means essentially is that every year that goes by, that truck is worth 90.5% of the previous year's value, which is declining by 9.5. So when you evaluate this equation at T equals 5, you get 16,998.12. So in 5 years, this truck that started out at $28,000 will be worth $16,998,000. Every single year, it's about 90.5%. it's worth about 90.5% of what it was worth the previous year. So your rate of decline is 9.5%, but your multiplier is 0.905. Okay, so this is the first of a few videos. So we want you to watch the other videos, and then you have a Flipgrid assignments that is your minor grade this week. So have a great week.